Good afternoon, colleagues. I'm Prashun, working with Semit Visa, and yeah, we'll be discussing few minutes about the cloud computation facilities. How we can use most of the free and open source resources, and yeah, have a quick result. So maybe I can start my presentation with.
Yes, you can. Just to give you a reminder, the session is timed for 60 minutes. I'll be giving you first reminder at 4 and another 4:15. You need to wind up by, sorry, I'll give you the first reminder after half an hour and then after 15 more minutes. You're
Don't
starting
worry,
at.
I'll wrap up earlier.
All right. Thank you so much. Please, all yours.
So just giving a background that the session is giving aims to give a quick introduction about the use of geospatial technologies over the cloud. And one of the major primary, we have a few other things like IBM recently started, but most common and free is Google Earth Engine. So it is a no cost facility, but yeah, when you'll be using a huge data set or you'll be using a huge bandwidth, it will charge a limit. But yeah, that's beyond the discussion now. So it has a huge data sets, and best part is that it has a very good community support. Who are programming already programming, they know that we have commonly use Stack Exchange, etc. And additionally, Google has itself a very good help facility, and regular users, they provide good support if you have any problem, post any problem. May I ask that if anybody already using Google Earth Engine? Okay, I guess
no, no.
I'm sorry.
Personally, I never used it, so it would be new for me.
Okay, great. So this presentation will be shared, obviously, but the code input window, this is the we cannot go directly Earth Engine Google.com. Input code dot etc etc. And the data catalog is in different domain into Google, but the developers etc. I'll go through and each and everything, but let's first have a quick overview. So this is the Google Earth Engine overview, which has a assets or the files you will be using on your left. In the middle, the coding window, and on your right, it has given kind of a processing update in error, etc. And at the lower part,
Sir, I think you are supposed to share a screen because we just see your face. We don't see screen.
Yeah, even I was going to ask, are you presenting something?
yes, I thought it's a just 1 second. This will slow.
We can see that you're presenting. Can you make it full screen or in slideshow mode?
You're on mute.
We can see the screen, but if it can be made full screen.
Okay, it's already full screen. Need to switch.
I
If you
think
can
you
go to the display
should
settings.
look at this display setting above.
Display setting.
Maybe
Duplicate. Yeah,
duplicate.
this one.
Good.
All good.
Great. Sorry for the inconvenience, and just let me make it minimize. Okay, so because I have just looking at two screens and it's a bit got confused. So in that Google Earth Engine GUI that looks like this, it has a on your left, it has a assets or the files you are using for analysis. In the middle is a coding window, and on your right, it has a three tabs, which is the inspector, which you can hover on a particular area and get to know that what it is. And it gives a kind of update and error message in console. And finally, in tasks, it help you to export to your Google Drive. And the lower part, it has a visual output what you have processed just now. I will go one by one with a exact or kind of proper example, but also just want to notice you there is a small tab here, geometry, that is also need to be remember when you're coding something. So how it works? Google Earth Engine, where you have lot of data sets inside, you call that use your assets in a case that in a chef file or a particular area of interest, you bring it, analyze it, and then see if it is in the right direction and then export it. But before exporting, you need to put one rectangle or define study area. Otherwise, it would try to export a lot of stuff which is not maybe desirable. So in the data catalog part, we have different kind of data sets. So I will first show you. Maybe let's go to. So this is the interface of data catalog. You can see there is a lot of data, different kind of data, and you can start with browse by tags. That would give you some idea of which kind of data that you are interested in. Say you are looking for some data sets which is in 16 days interval. Are we familiar with the name with MODIs? Hello. I'm trying to
No,
make it interactive kind of thing. So please
no,
keep your
no,
mind.
sir, no.
Are you familiar with the MODIs? The name of MODIs, MODIS?
No.
Okay. So MODIS is one of the most frequently available data set which is provided by NASA, and it has different spatial resolution, 500 meters, 1 kilometer, 250 meters, and higher and lower resolution, and different temporal resolution. I'll say weekly, 16 days, not weekly, actually 8 days, 16 days, etc. And if you go back, again, say go by tags, you are assuming you all are from agricultural background, you can have a look, say biomass. Suppose you want to know that what is above ground biomass in agriculture or forestry, you can find it from here. And most interesting thing is that when you click any of these, they provide a small code. So without knowing JavaScript or any programming efficiency, you can start directly. If you click here, they can see. Yeah, they can. Yes, screen sharing. Okay. Screen is shared here. Connection. Okay. So once you click in that, it would show you this open where we're talking about earlier. One is script, docs, asset, etc., etc. And this is the main coding window. And if you click run, it's showing it the biomass of the whole globe. That is a bit overwhelming data set, isn't it? Too much data. We might be interested in somewhere in Africa, or maybe South America, or maybe Indonesia. So that is too much data to handle. I'll just go and show one more data set. Maybe temperature something, because in irrigation scheduling, maybe you will be interested for temperature data sets. So there is different kind of temperature observed and model from climate models. Data is available here. Maybe for the timing you will not be required, not, but if one started to get used to with this data set, you will find that this is a huge data sets and enormous if possibilities are open for you. Do you want to comment anything about that data catalog or any question? Okay, let's start with a small example. So, have you heard about global land use, land cover datasets? Anyway, so let's start with here. We are trying to visualize and extract the data sets from world land use land cover, which is actual resolution is 10 meter, spatial resolution 10 meter. How we can clip paste on our area of interest, and what is the resolution we require to export it. This code is already available in that CG folder. You can run this code on your own. If you firstly, obviously, you need to open a Google Earth account, and I gave a South Asia outline. You can put something else, whatever you preferred, and then when you run this program, let me start with the line by line thing. First is that we are calling a table. This table is South Asia outline, which is chef file. Then we are calling a land use land cover data, and then using this function, we are clipping out except the South Asia internal part. And then we are looking for particular one class. So let's see what is that class here. This is a data set I'm presently discussing, and it has around 10 classes. And out of that, we are presently interested in this class, cropland, which has a value of 40%. So what we are saying that in that cropland data, whichever we have called earlier, only the equivalent 40 we are requesting from that whole data set. Rest we are excluding. And then we have used a small function kind of thing defining what should be the color, just to visualization, nothing to do with analysis. And then when we press the run button, it returns an GeoTIFF data which has only cropland area, which is equivalent to 40 class according to us. And this already ready to export. If you run it, it would have in a particular folder, which in my case, I gave this name, CLULC. You can give it whatever you name, but this will be stored in your G drive. And few more things. This is a description, which the file name will be. What will be the scale? That is spatial resolution. What would be the projection? And the geometry I was talking about earlier need to be more careful to use it. Otherwise, it would cut or it would exclude some areas. In our case, the geometry is covering whole study area. Once you can just click and drop anywhere, you can make another like a point. And this has been already defined here as a polygon, the red one. So once this run is complete, this is already in your folder, and you can further use whatever you like to do. Any question or any discussion about this small code? Before I go for next example, anybody like to say anything?
Okay, participants, as I told again and again, this has to be interactive because these things require a kind of whatever you understand or you may not be, because this is fast, he is moving and he is bit slow compared to other. So please, if you have any query, you please ask.
Anyway, next go to the next example. Earlier, we have just called one data set and just cut some part of that the whole data set, which is our area of interest, and then we export it. Here we're trying to do, we are calling two data sets. One is night light, which is a kind of average radiance, another is land use land cover. If you go through that small notes I put in that CG drive, it would show you what is the purpose of this. Let me see if I can find here with my, whoa, too much. Yes. So this note is already there in the Sky Drive. The purpose is finding out the electricity, access to electricity in semi-rural and rural areas. I have used two data sets. One is night light, another is LULC. So after calling these two data sets, we need to get the exact class or exact value which we are looking for. If you go to this mode is land use land cover data set, এটাকে অফ করবেন পরে এটাকে উপরেরটাকে So in this land use land cover data set, we are using first LC type 1. If you see in this code, we are using LC type 1. And out of that, we are requesting particular class. NEQ means not equal to. Out of that, which is not equal to 13, we are masking rest of the things. Why we are only extracting 13 data? Because purpose of this exercise is to find out where electricity available in rural or semi-rural areas. In this class, mostly 13 class is related to urban or built up areas. But anyway, it is, we need to understand one thing, that remote sensing is not perfect 100%. So it has obviously some bias, some of the errors which you need to further estimate it. So in this line, we are trying to say that whatever in that image other than 13 class, mask it out. And then we get another file or data sets. And further, we are multiplying with this land use class, which is equivalent to 13, and night light. It shows something like this. So this is the how Africa looks like in night. You can see the Nile Delta and the Algeria area is having more night lights, though we have been excluded the city areas. The city periphery has still a lot of still brightness or radiance from the energy, some energy. We are assuming it's a kind of light, or that as a proxy of access to electricity. So in this code, if you change this, say, if you remember where we define this filter, if we change this filter or the area of interest and rerun this program, it will give you some idea of how it look like for South Asia. So as we can see that without much effort, without much data download, data pre-processing, etc., we can get some very quick and ready-made results. So in that case, what we are trying to do here is trying to understand access to electricity in rural areas. Being an agricultural scientist, you might like to know that if there is an agriculture, there is no access to electricity, whether there is the potential for solar pump. And this kind of application is could be quickly extracted information where you can take a call, what you need to do. This is a small few lines program, but Google Earth Engine is quite powerful. We can take this example. It's quite long code, like 350 lines. What are we trying to do? As you know that agricultural productivity and estimating productivity in granular scale, one of the major indicator that how over the time productivity is changing, whether there is any kind of impact from climate or any kind of management practices. So this over the time productivity, which is we are calculating primary productivity, it would give us a good idea what is happening on field. So if we just run it, it takes some time because it's calling, if you can see here, lot of data sets it's calling that includes solar radiation, temperature, water, etc., etc. And then finally, it's giving you some data sets, which is showing that red to purple is higher and blue to green is lower. Who are familiar with this area, they might know that the Indo-Gangetic plain has obviously almost always higher productivity because of the irrigation and very dense agricultural practices. Additionally, this area is a deserted area in India-Pakistan border, where we have a low to almost zero primary productivity. So, as we discussed earlier, that primary productivity can give you a kind of understanding what's happening in agriculture in on field, and you can take a call or take a decision that what could be done. Here we are just calculating over the monsoon period in 2019, you might calculate for 20 years or 30 years of data and see the trend and try to understand whether that productivity is in the increasing trend or decreasing trend, or it is a dip and then again increase, whatever happening over that certain period of observation. Do you have any point to discuss here? I would like to try to make it more interactive. It would be great if you can come up with some question or maybe your insight about it.
So, do we have anything from participants then? Any question, any thought, any remark on what has been presented till now? Anyone? No one?
Great. Oh,
I don't see anyone posing any question as of now.
but anyway, they will have my email ID if they can contact me later on.
Sure.
Thank you, Jira. So let's go to another example. So just for this code and the other code I already available in that CG web space, and you can just copy and paste, but obviously you have to upload those files which are provided in separate folders. Then you can run it in Earth Engine itself without any kind of thought. You can try it and then try to improve it. So another example is data visualization, where I'm trying to show you that erratic climatic pattern, precipitation anomaly, or uh, early setting of monsoon, really important for agriculture. So if you, this is a small app where you code in backend in Google Earth Engine and make a small app out of it. You can share it over the net to other users or other researchers and come up with some idea of what is you are trying to understand. So let's see this app how it works. What is trying to do is over the certain time period, it's looking for each and every day whether the precipitation is more than 64.5 millimeter. And why 64.5 millimeter? Because it's a kind of standard, at least it's in South Asia. If rainfall or precipitation is more than that, we'll consider it as a kind of higher side, which might not be beneficial, and it can bring some floods or damage in existing crops. It takes some time because it's calculating large number of data set over the year. Let's wait few seconds, let it load home. Taking time, so I just already did it. I was expecting it will take too much time. So from this panel, you can choose a particular kind of point of observation or draw your polygon or draw your rectangle, and you can report it in like this. So let's choose a point because it's a less time consuming. When you're clicking it, it would calculate and extract for that point all the observation over I guess 5 years I have did it, and it will generate a chart from how many years I have to check? 1, 2, 3, 4. Yeah, I think 3 or 4 years. So it would show you that daily rainfall, and you can export it in CSV. You see, download as CSV or as a just image. So if it is required, you are interested in a particular area, particular point, particular area, you can extract that value and do for further analysis. Same way, I just taken an example of precipitation because it might be looks more interesting for you, but you can take it like a observation plant health. Are you familiar with the NDVI or vegetation index?
Tell participants, please tell. We have covered NDVI at least.
No.
NDVI we have told so many times. I told you. Then Pooja told.
So let's recap once again.
Also told you.
NDVI is a kind of index where we use.
So sorry to interrupt. Just so you know, we're done with half an hour. You have half an hour more. I'll give you another reminder after 15 minutes.
Sure. So NDVI is a index of two wavelengths of the electromagnetic spectrum. One is infrared, another is red. So you just divide it. If it's NDVI, it's like a Ni minus R divided by Ni plus R. There is another kind of lot of vegetation index there, which is sometimes soil adjacent, savvy, or etc. different kind of things. So in this, NDVI actually reflects you or give you some idea what is the vegetation health on ground. It usually ranges from -1 to +1. -1 is dead or nothing there. +1 is very healthy. But anyway, +1 is kind of theoretical stuff. Usually we get like a 0.6 to 0.7 is max. So instead of precipitation, you can bring or call NDVI data from Google Earth Engine and plot the same way. I'm plotting for maybe 3 years. You can plot for 6 months, which may be life cycle of a crop. And you can have a clear idea which time. I mean, basically it goes like goes up when the plant maturity, and then before harvest it goes down to 0. But if you see some part of your data or some part of your area of interest, there is any dip, there is some problem with plant. It could be, say, lack of water, could be some pest and disease infestation. But anyway, at least we can find it that what is happening there. You can also link with what is happening there with the other than vegetation data. You can get it from evapotranspiration data, which is also available here, temperature data, all available here. So when you talked about anyway, let's see here. Here, if you just put N, so there is a lot of NDVI datasets or vegetation in the datasets, not NDVI actually. There's also AVI also here. Different spatial resolution, different temporal resolution. And if you click any of the thing, it would give you some idea what is it, description. It would give what the bands it has, what is the resolution, and a small code. Without anything, you can just run with it. But obviously, we have to have one Google Earth Engine account. Loads here, we just hit run. More green, more NDVI, more yellowish to brown, less NDVI. So we can see from this inspector console, let's see in the Myanmar area where that it at least looks like very green. Let's look in that part. So in February, it was very green and then it went down, maybe some forest or something. But why this data set is so big range? Do you have any idea? Can you see it from here? We just talked about that we have a NDVI range -1 to +1, but in our plot, we can see the data set going to 9,000 to, because it uses a scaling factor 0.001. So be careful when you are downloading this data. Don't forget to multiply it and download it. Why they use it? Because if you use a kind of float image, that might be sometimes too big to handle. If you use the integer kind of value, then it doesn't have that big size, or cloud. When you download as a cloud optimized data, it keeps the integrity. So it's coming like a 0.012, and highly vegetated area it's 0.8. Anybody of us are interested in a particular area where you like to use Google Earth Engine? I mean, we have a lot of examples here. We can have a quick idea that if you have a particular area of interest to work on.